This definition of calibration, this particular definition of it, is not about approval or disapproval of a device. So sometimes we use a go, no-go gauge to see if something has been made correctly. Or we, well, going back to the gun analogy, we test the gun and see, is this thing working well enough for us to sell it, or is it not working well enough? We're not talking about approval or disapproval here. Calibration is basically figuring out what it does now, including its precision, and it says including how precise it is, so we're measuring its success. And if you've got calibration information, then you can interpret the signals correctly, and so you can correct the accuracy, and you may be stuck with whatever precision you've got, but at least you'd know. So calibration is just the process of figuring out what it does. And we tend to extend that definition a little bit to say we're going to calibrate that equipment. We tend to include with that sort of fixing any problems we run into. But the calibration, according to this definition, is just the idea of measuring its performance. To transduce something. So the back half of this word is the duct, basically. So we have, so duct basically refers to something flowing in a particular direction. A conduit for air could be referred to as an air duct. So we've got that kind of indicator, and then we've got trans, which means across. Sometimes trans refers to changing, but at its root it basically means across. It's similar to a word like diagonal, but it's not putting things, it's not sort of with things. That would be conduction. This is transduction, which says we're changing it or taking it across something. So what are we changing here? Well, we're going to carry something along and change it. So if you get a signal and you convert, well, if you have a sensor, it picks up on some information and it converts that into some other kind of signal, then it's a transducer. So if we measure temperature and we convert temperature to a voltage or a resistance, that's a transducer. So key to that is this idea of converting. And in our models, we're going to be dealing with electrical signals. So the thermostat for your home, when you pass a certain level, it starts an electrical signal. It brings a voltage high that was previously low. A microphone turns sound pressure into electrical signals, etc. I've written here that this definition is needlessly narrow because not all signals are electrical. Built into their definition is the word electrical. But quite a few of them are. So that's the subset of the world we're going to talk about is one in which signals are electrical. Sensitivity is the ratio of change of a signal to change of the measured physical parameter. So if I see a signal coming down my wire, maybe I've got an analog to digital converter here, and it tells me that at a particular moment in time I had 4.92 volts. Well, sensitivity has to do with what does a given amount of change in this voltage actually mean as far as the measured parameter. If the measured parameter is flow, then I need to know how many gallons per minute correspond to a change of 0.1 volts, perhaps. So how much does my signal change for a given change in the measured physical parameter? Hopefully, to make life easy on you, you've managed to find some kind of sensor and measurement equipment that leads to a linear relationship. So if every gallon per minute is 0.126 volts, I just made that number up, but if it's exactly the same for every additional gallon per minute, then we have a linear sensitivity. Otherwise, we might end up with a system that's, really sensitive to the first few changes in gallons per minute, but then as time goes on, as the flow increases, it gets less sensitive. So we get less of a delta V for a given change in measured parameter, in this case gallons per minute. In that case, we've got a little bit of a problem. We're either going to decide, well, this sensor then is only to be used in this linear region, or we've got to have sort of lookup tables or some way of accounting for these differences over time. So it just makes it more difficult to deal with. So hopefully our sensitivity is linear.